Okay, now I can see it.
Okay, awesome. Thank you. All right. So, yeah, so we're solving this, right, trying to get y by itself, which we did here. And so now, right, the number that's in front of our x, right, that's our slope, and this other number is our y-intercept. Okay, so we found two of those things, the slope and the y-intercept, right? But how do we find x-intercepts? You guys remember? How do we do that? We gotta let y equals 0 and solve for x. Okay? And so when I do that, I'm going to have negative 2x plus 4 times 0 equals 15. Well, 0 times anything is just 0. And so I'm left with negative 2x equals 15. And so I need to divide by negative 2. So x equals negative 15 halves. Right? So this is my x-intercept, but I want to make sure that you remember that you should write these down as ordered pairs when we're talking about x-intercepts or y-intercepts. So when our y is 0, we found our x to be negative 15 halves. Here, right, when x is 0, then our y is 15 fourths. So make sure that you know how to write those as points also, because you know, x-intercepts, y-intercepts, they are points on the graph. Okay. All right. Let's see. We've talked about. Yeah, I think I'm going to go on. There's not a lot of stuff from this first part that is usually tested on, just because they're kind of hoping that most of it, you know, you got in 980, but it was kind of some review. But let's look at one like 7D.
So since I hopped on late, where are you getting this review?
This is in the final exam module where it says, okay, you know, so this is the 2019 objectives review.
Oh, perfect. Okay, thank you.
All right, so let's look at 7D now here. Like I said, we're just going to kind of look at some of these that I feel will be most beneficial for you. So if we're trying to write an equation of a line that goes through the point 3, negative 3, and perpendicular to the line 2x plus 5y equals 4. All right, now we talked about some of these in class, and so I hope you are getting the idea that this is an important one to know how to do. Right? So to solve, or to be able to write an equation of a line like it's asking you to do here, we got to first figure out what the slope is. And so let's solve this, get y by itself so that we can do this. Right? So that's going to give me 5y minus 2x plus 4. 5y equals, and then divide by 5. So y equals negative 2/5 x plus 4/5. Okay, and I don't care about the 4/5 on this because it's just asking me to find the slope, but I don't want just the same slope, right? I want the perpendicular slope, which is going to be 5 over 2, right? I've got to flip it and change the sign. So I'm going to be using 5/2 for my slope. Okay, and then I'm going to be using this point. This is my x, this is my y. Okay, so if I plug those things into my y equals mx plus b, well, so I'll have negative 3 in place of my y. I'll have 5/2 in place of my m. I'll have 3 in place of my x. And then all I'm left to solve for is that y-intercept that I need in order to write the equation of a line. So here I get negative 3 equals, multiply those together, 15 over 2 plus b, and then I need to subtract that 15/2 over. Okay, and some of your calculators will do that, but if not, remember that you have to get a common denominator, so it's really you're doing -6 halves minus 15 halves. Right, that's what you would do there. You got to get a common denominator on that one. But like I said, sometimes your calculators will do that for you. And then you have -21 over 2. And so that is your y-intercept. So now I know my slope, I know my y-intercept. So again, I'm going to come back to this equation and put those two things in. Right? And with the equation, we have y equals 5 halves times x, and then minus 21 halves. And so that would be your answer. That is your equation of a line that goes through this point and perpendicular to that line. Okay? All right. Let's see here. Let's make sure you know how to do solving some systems of linear equations, right? So the next thing here, and I talked about it in some of my classes, but remember, it's not going to ask you to solve anything using matrices, because we can't check that you're using matrices to solve it since you're not uploading any of your work. So if you're stressed about having to use matrices to solve any of these, don't worry about it. You can do it with substitution or elimination, and that'll be just fine. Okay? All right, so then
Pretty good.
let's look at some of these. I think you're pretty good on how to solve by substitution and elimination, but let's look at one of these story problems of sorts here. And let's do this hiking club one. That'll be a good one to look at. So the hiking club wants to sell 50 pounds of an energy snack food that will cost them $1.80 per pound. The mixture that will be made up of nuts that cost $2 a pound and raisins that cost $1.50 a pound. How much of each should they buy to obtain 50 pounds of the desired mixture? Okay, so on this one, there's two different things that we're looking for, right? We want to know, the pounds of nuts and pounds of raisins. So maybe I'll just call pounds of nuts, that'll be N, and pounds of raisins is going to be R. Okay, and then we have to make our little, you can make a little chart up for this if you find that's easiest way for you to set it up, but you're going to have to come up with two equations here, right? And so remember we talked about how across the top we're going to be putting the things that we're mixing together, and then along the side here is going to be and looking at our labels or the units and stuff like that. Okay, so the things that we're mixing nuts, we're mixing raisins, and then we want to know about the mixture, right, of those two. And we're dealing with, so our labels that show up in our question are pounds and money, right, the price of it. So when we're looking at just this top one, right, so we don't know how many pounds of nuts and pounds of raisins, because those are the two things we're trying to find. So, but we said we're going to call that N and R, right? But the total mixture, right, is going to be how many pounds? Oh, were you okay? All right, so the total mixture is going to be 50 pounds, right? So we need to put 50 there. And then we want to talk about how much each of them costs. Well, it says the nuts are going to cost $2 a pound, raisins are going to cost $1.50 a pound, and we want the snack mix to be a total of $1.80, right, a pound. So this top one is going to give us our first equation, but then we need to multiply the first and second row together to really get our second equation, right? So $2 times the number of pounds, so we'll have 2n. $1.50 times the pounds of raisins. And now make sure that you remember, right, it's not giving you the total, amount, like how much the total amount's going to cost or anything. So you have to do the 50 times the $1.80, which is going to be $90. Alright, so to get that, we did 50 times $1.80. And that's how we get that 90. Alright, so then our two equations, let's write those over here. So n, however many pounds of nuts, plus however many pounds of raisins, right, is going to be, we need 50 pounds of them together. And then we have 2n plus 1.5r equals 90. Okay, and now you can use the substitution or elimination method to solve that. Okay, so give you a minute. I want you to try that really quick. Let's see what come up with there. So you could do this either way, it doesn't matter. I'm going to choose to do it by elimination. So I'm going to multiply the top equation by -2 so that when I add it to that one, those will eliminate. So I have -2n minus 2r equals -100. So then I'm left with -0.5r equals -10. And then I need to divide by -0.5. Okay, and whether you did this by substitution or elimination, remember it doesn't matter. You still will get the same answer either way. So you should get r equals 20 on this. Right? So when you do -10 divided by -0.5, r is 20. So that means we need 20 pounds of raisins. And then to find out the number of pounds of nuts, remember, well, we know that it's 50 together, so we're doing 50 minus 20 gives me 30, right? So we must need 30 pounds of nuts. Okay. All right. So make sure you know how to set up these type of problems. If you're like, oh, I'm kind of fuzzy on those, make sure you work through a few more of those type, right? There's a few here. You can look on quizzes. You could look on, reviews and stuff like that and get that. Okay. We talked about solving systems of like the 3x3 ones in class. I wasn't going to do one of those unless you're really wanting me to, because I want to make sure that I can get through, everything that we want to talk about today. But make sure you know how to do those 3x3s. Okay. And if we don't have time, but you want to go over it at the end, then let's do that. Okay.
Becky, I remember in class you said something about matrices and matrices. Are we going to have to solve a matrix in the test? I forget.
Nope.
You said.
Nope. You do not need to know how to do matrices for the final. So as long as you know how to do the substitution and elimination method, you're good. And then solving this 3x3. Yep. So don't stress about matrices. I would say don't even spend any time trying to do anything with them. Okay?
Great. Thank you.
Yeah. Okay, let's look at the next stuff. So we want to make sure that we understand about solving absolute value equations and absolute value inequalities, right? And so, let's see, some of these have like A and B on them, but so 16, number 16, I want to look at that second one there. This over here. So I'll put it down as 16b, even though it doesn't really say that, but it wants us to solve for minus 3 times the absolute value of x minus 6 equals 7. Right? So first thing you need to do whenever you're solving something with absolute values is you've got to get the absolute value part by itself. So I'm first going to move this 4 over. Be careful, you don't do the 4 minus 3 first, right? Because remember, this 3 is connected to that absolute value by multiplication, right? And so when I'm thinking about how I would undo this, I'd want to subtract my 4 over first. And so then that will give me negative 3, absolute value of x minus 6 equals positive 3. And then I need to divide both sides by negative 3. Okay. And then here, so the absolute value of x minus 6 equals negative 1. Right? And, I'm going to show you how to solve this out, but then talk about, what we come up with here. So remember that if you were to try and solve these out, you want to make two different statements. So our first one would just be like it is without the absolute values. And the other one, you need to change the sign of that number on the right-hand side. And then when I solve these, right, I get x equals 5. And here I get x equals 7. However, if I go and I try and check these, right, let's see what happens here. So here, if I put 5, right, into this, I get the absolute value of 5 minus 6. And so I get negative 1, the absolute value of negative 1 is 1, so we're saying 1 equals negative 1, which is not true, right? So this is not a good solution. If I do 7, 7 minus 6, absolute value of that is 1, and 1 does not equal negative 1. So this is going to end up being a no solution, right? But how could you see that by looking at this statement? Anybody know? How could we do that?
The absolute value can't equal a negative number.
Exactly, right? So absolute value can't equal a negative number. So right there, we didn't even have to go any further. We could have looked at that and said, oh, that looks weird. My absolute value can't equal a negative number. So that's why we end up with this no solution for our answer. Okay. Make sure you work through a few of those, the absolute values. Okay, let's look at, let's see, skip over that too. Alright, let's look at some things in here. Make sure you know how to, multiply different types of polynomials together. And I know some people were kind of worried about whether you're going to have to do U substitution on the final. You don't, so don't worry about that. Okay, but know how to do, factoring, some of these, especially ones that, where your leading coefficient isn't just a 1. So let's look. Yeah.
Yeah, can you show us that, it's like that quick way to do it if your leading coefficient isn't 1. There's like a trick you taught us, I can't remember.
Yeah, so that's called synthetic factoring. So that's the way, at least I think that you're talking about. Let's look at it this way. Okay, so if we're looking at this one, so this one looks kind of like a beast to try and factor, right? So this 12x squared minus 11x minus 15. So remember, the first thing you need to do is you're going to multiply. Well, the first thing you'd always want to do is see if there's a greatest common factor, right? That can factor out. And there's not. So then we're going to do our A times our C, right? So 12 times negative 15 is negative 180. And this is a pretty big number, right? And so we want to break this down though and think about, okay, what are the different factors that could make up this, all right? So what multiplies to be negative 180 that adds to be negative 11, right? So you can kind of work in an organized fashion on this, right, to help you get there. But remember, like, I mean, you know, so you could do like 1 times 180, 2 times 90, right, 3 times 60, and so on, right? So does anybody know what that combination would be? What multiplies to be negative 180 that adds to be negative 11?
It's 9 and 20.
Yeah, it's going to be 9 and 20. All right, so you can just kind of keep working these out, right, and keep going. And then our 20 is going to have to be the negative one, right, to get the negative 11 in the middle. So then you take what that winning combination is that you found, right, so that 9 and negative 20. And then you're going to divide each of those by what the leading coefficient is. So we're going to divide these by 12x. And so really what I'm going to end up doing here is just simplifying these fractions. Right? So if I am reducing this first fraction, I can see that 3 divides into both of those. Right? Leaving 3 there, and this will be 4. Right? Here I can see that 4 divides into both of these, leaving 3 and negative 5. So then when I'm writing my answers down in factored form, I've got my 4x plus 3, so that's a positive 3, and then 3x minus 5. And that is my factored answer. And if I FOILed these back out, I would come back with what I started with. Okay?
Thank you.
Yeah, so hopefully that helps you. And if you're not a fan of the synthetic factoring, that's fine. You can do it the other way where you're doing, you know, like the factor by grouping. You still have to come up with that winning combination, but then remember you've got to make it into a 4-term polynomial using the 9x minus 20x. Right? And then you can just split it in half and do the factor by grouping, and you'll still come up with that same thing. Okay? So make sure you know how to do factoring, you know, like factoring those trinomials for sure. Okay? Because on a lot of them, you are going to be, you're going to be using the factoring on some of the other things, kind of like we'll go through a lot more in the rationals because that will do more factoring there. So if you're kind of worried going, oh, we want to look at more factoring, we will when we do some of those. Okay. All right. So let's look at 25, this application. So it says, a window washer accidentally drops a bucket from a top building, or top of a building that's 76 feet tall. I can talk. The height of the bucket above the ground after t seconds is defined by this function. Right? So they give you this s of t, right? So this is the height after t seconds, and it's negative 16t squared plus 576. And it wants to know, when will the bucket hit the ground? I hope it doesn't hit anybody. That would really not be good. Okay, so when it says something like that, when will it hit the ground, right? What do we need to remember? What is that telling us that we need to do?
You need to equal it to 0.
Yeah, so it's saying when is our height going to be 0? So I need to put 0 here and then solve this. Right? So you could try and factor it. You could try, if you couldn't figure out how to factor it, you could use the quadratic formula, right? But you got to make sure that you kind of know how to do this. But let's look and see. Does 16 divide into 576? Right. Yeah, it does. So let me rewrite this out here. So if we take out our greatest common factor of negative 16, right, then that's going to leave me with t squared minus 36, because 576 divided by negative 16 is negative 36. Okay. And then I want to keep factoring that. You see that's a difference of squares. So that's going to be t plus 6 and t minus 6. And then if I set each part equal to 0, okay, so if we set 0 equal to all of those things, so 0 equals negative 16, 0 equals t plus 6, and 0 equals t minus 6. Well, this first one is just nonsense, right? There's no t to solve for, and 0 does not equal negative 16. Right? On these other two, right, we'll get t equals negative 6 and t equals positive 6. But are both of those good answers for what we're trying to find? What does t represent?
Second.
Time.
Yeah. So again, right, you got to see that that is no good. We can't have negative time. So our answer is just going to be 6 seconds. Right? So it's going to take 6 seconds for it to hit the ground. That's what we're finding there. Okay, but again, like I said, if you didn't want to factor this, you could use the quadratic formula. But make sure when you're using the quadratic formula, you have to use the numbers that you start off with here. You can't use this in factored form. We saw some people trying to do that. And so if you're going to use the quadratic formula, you're going to have to let a equal negative 16 and c equal 576. You can't factor it and then use that stuff inside. It doesn't work. Okay, you've got to use those two numbers there, and then our b is 0, because there is no b term. All right, let's look now at some rational expressions, rational equations. This always is the part that's hit pretty heavily, it seems like, on the final exam. And that's because, it kind of has a lot of things in it, where it's asking you to do some factoring and stuff like that. So I want to make sure that we are, seeing that. So let's look at 29. I think that would be a good one to do. So 29, and I'm just going to write this down. I mean, it just says f of x is this, g of x is this, but then it wants you to find f of x divided by g of x. Right? So really you're dividing these. So I'm just going to write it down as a division. So I'm going to have x squared minus 9x over x squared plus 3x plus 2. And that's all going to be divided by x squared minus 81 and x squared plus 2x. Right? So remember, when it's division, right, you're going to want to factor everything, but whenever you're dividing fractions, right, you've got to flip that second fraction. So you might, it's fine either way, whether you want to, like flip it first, change it to multiplication, or whether you want to factor it first. I'm just going to flip it first so we don't forget to do that. That could be something that happens as students forget to flip it. So x squared plus 2x is on the top, and x squared minus 81 is on the bottom, and now it's connected by multiplication. So now I just need to factor every single thing, right? All of these different polynomials, and I'm just going to make one big fraction, because any factor on the top will be able to factor out with any or divide out with any factor on the bottom. So up here, this x squared minus 9x, I can see an x can divide out of that, leaving x minus 9. Over here, I can see an x will divide out, leaving x plus 2. On the bottom, right, this is a trinomial, so I can go straight to Hippobutt's. What multiplies to be 2, that adds to be 3, well that's going to be 2 and 1. And then this is a difference of squares, right? That's going to factor to be, so I'm thinking, x times x is my x squared. What multiplies to be negative 81, that adds to be 0, because there's no x term there in the middle. And so that would have to be negative 9 and positive 9. Okay. And now I just want to start dividing out anything that I can, right? So I can see that this x minus 9 and this x minus 9 will divide out. The x plus 2 and the x plus 2 will divide out. Okay? But there's nothing else that can divide out there. So then I'm left with x times x, which is x squared, and then x plus 1 times x plus 9 on the bottom. And so that would be my answer. Okay, let's look at the one. Now let's look at the subtract one, because the subtract one tends to have more, usually there will be something like that, like there might be a multiply or divide question, there might be an add or subtract question, right? But with the subtract, that tends to have a little bit more problems just because of that subtract sign. So let's look at this one. So if we're looking at, I guess this is kind of like 30b, I don't know. All right, so I have 2x over x squared minus 9 minus 3 over x squared minus 4x plus 3. Right? So in order to subtract these, right, I need to get a common denominator. And the easiest way to find our common denominator is to factor those denominators first. So this x squared minus 9 will factor to be x plus 3, x minus 3. And then let's see how this one will factor. All right, we'll go straight to Hippobutt's. Oops, that looks like it's going to be x minus 3 and x minus 1. Okay. And so when I'm looking to find my LCD here, right, every single part needs to be accounted for. So that means the x plus 3 and x minus 3 are part of it. Right? This one already has an x plus 3, but we also need to account for that x minus 1. So we're going to have 3 different factors here, right, that make up our LCD on this. Let me write this down. So my LCD that I'm going to be coming up with is going to be that x plus 3 times x minus 3 times x minus 1. But then I'm going to look at each of these and say, let me get rid of those parts because these are factored now. So I'm looking at this denominator saying, okay, it has the x plus 3, the x minus 3, but it's missing the x minus 1. So I need to multiply the top and bottom by x minus 1. Okay, on my other fraction, it has the x minus 3 and the x minus 1, but I'm missing the x plus 3. So I need to multiply that on the top and bottom. Right? And with this subtract sign, this is like I said, a lot of people make a mistake with this. I would change it to add a negative 3. So you remember when you're distributing this through, you're distributing that negative. Not a positive 3, but you got to distribute a negative 3 there. Okay. So then on the top, when I distribute this through, I get 2x squared minus 2x here, negative 3x minus 9. Okay. And so if I combine my like terms together, I get 2x squared minus 5x minus 9 all over this. And then you'd want to look and see if this would factor right? It's because maybe it will cancel out, one of the factors there will cancel out with one of those factors on the bottom. So we're thinking, you know, so if we're just trying to think through it, 2 times negative 9, so what multiplies to be negative 18 that adds to be negative 5? Is there anything? 1 and 18. There's 2 and 9. There's 3 and 6.
3 and negative 6?
Yeah. Well, no, wait a minute. That's not going to give us a negative 5.
Oh yeah, never mind.
Yeah. So it doesn't look like, right, those are our only possibilities. And so it doesn't look like it will factor, which is fine. Then we just leave this whole thing right here is our answer. You want to look and see if it will factor. Sometimes it will. Okay, so remember when you're adding or subtracting fractions, you've got to get those common denominators. And when it's subtract, you know, make sure that you're distributing that negative through there. Okay. So remember, if there was like a multiple choice on this one, you know, they know that sometimes students will forget to put that negative through, right? And so that's what happened there. Okay, but let's compare this to number 32, because oftentimes students get confused between the difference between this one that we just did on 30 and 32. So 32 is not telling us to add or subtract, right? It's telling us to solve, because now we have an equation. We didn't have an equation up here. Those were just, you know, expressions. So all we could do was add or subtract them together. But now we're trying to figure out what is x. So here we have 6 over x plus 4 plus 3 over x plus 3 equals 15 over x squared plus 7x plus 12. Okay, we'll start this off the same way, where we want to make sure that we factor all the denominators, right, so that we can see what we have there. So I'm going to factor this. So 3 times 4 is 12, and when I add those, I get 7. Right. So then I want to know what my LCD is, not to make the fractions, but to be able to kill off the fractions. So remember, I can kill off these denominators when I have an equation. Okay? It only works with an equation. Right up here, we had to work with the denominator. Okay, so here, right, I'm going to multiply each part by the x plus 3 times x plus 4. Whoa. And so then I'm going to see what will divide out here. So this x minus 4, or sorry, x plus 4 and that x plus 4 divide out, right? I killed off the denominator there. There's no denominator left. What I'm left with is just 6 times x plus 3 on the top, right? Over here, right, on the next one, my x plus 3's divide out, right? So I killed that denominator, leaving me with 3 times x plus 4. And then on this last fraction here, the x plus 3's and the x plus 4's, both of those divide out, and so then I'm only left with 15. Right? And so I have no denominators here. Looking at this going, I can totally solve this, okay? But remember also, I meant to write this at the top, whenever we're dealing with, you know, if we're trying to solve something with fractions, remember that we can't divide by can't divide by 0. So we always want to state what x could not equal. So on here, do you see x cannot be negative 4 and x cannot be negative 3, because those are the two numbers that would make our denominator 0. So we can have x can be any other answer, just not these two. Okay, so before we start solving this out, I want to make sure that we keep that in mind. Alright, so now let's distribute through. So we get 6x plus 18 plus 3x plus 12 equals 15. Let's combine like terms. And then subtract my 30 over. So 9x equals negative 15. And then if I divide by 9, I just need to reduce that fraction. Alright, so 3 will divide into both of those, so I'll get negative 5/3. Alright, so this is what I came up with for my answer, and that's got to be a good answer because remember, if I came up with negative 4 as a solution or negative 3 as a solution, then I'd have to say, nope, can't have that as an answer. Okay, so you always want to check and see if there's going to be some x's that don't work. But we're good. X equals negative 5/3 works on this one. All right, are you guys seeing the difference between 30 and 32? All right, so here you have to work with the denominator because it's an expression, but if it has an equal sign in it to start off with, then you can kill the denominators. That makes it a lot easier to solve. Okay. Let's see. How are you guys feeling about synthetic division?
Feel okay about it.
Yeah, that's the same here. I feel pretty good about it.
Okay. Alright, let's go find some things then that maybe a little bit more tricky. Alright, we definitely want to make sure you know how to use, the properties of exponents, right? And so let's look at some of these. All right, maybe let's just look at, I want to do one with where we have the fractional exponents, just to make sure. Right? Okay, and make sure you're not speaking out if you have anything, sorry. You guys still hear me?
Yes.
Yeah, I can hear you.
Okay. The person said they couldn't hear me. Darn it. Don't know why. Okay, so let's look at these fractional exponents. So if I have x to the 2/3 power times x to the 1/2 power, all divided by x to the 1/7 power. Or wait a minute, that's negative 1/7. That's hard to see there, right? So whenever we have negative exponents, right, that's going to flip upstairs, right? So really, I end up with x to the 2/3 power times x to the 1/2 times x to the 1/7, right? So remember that this 1/7 isn't what's flipping, it's this whole thing, right, is coming upstairs, and now it's no longer negative, it's now positive. All right, but if we're connected here by multiplication, then that means we need to add our exponents together. So we're trying to add 2/3 plus 1/2 plus 1/7. And so we need to get a common denominator here, right? So it seems like, wow, is 42 maybe the lowest? I'm getting 42 by just multiplying all of them together on the bottom. That will always give you a common one, whether it's the lowest or not. It doesn't really matter, but let's rewrite these as blank over 42, blank over 42, blank over 42. Right, so for 3, right, we're thinking 3 times what gives me 42? Well, it's going to be these other two multiplied together, so 14. 3 times 14. So I need to multiply by 14 on the top, so that's going to give me 28. Here, I need to multiply by 21. And 2 times 21 gives me 42. And then here I need to multiply by 6. Right? And now that I have that common denominator, I can add those all together. And remember, like if your calculator will do that, you know, for you and stuff, you're fine. I mean, you're not going to be showing work and stuff, so it's fine to just leave that. So that will give you 55 over 42. So your answer would be x to the 55 over 42 power. Okay, so just remember with, you know, whenever you have fractional exponents, you're still going to treat them the same way that we do with the regular, you know, same properties of exponents apply, I guess is what I'm trying to say. Okay. All right. Okay, let's look at number 41. So this is a FOIL, right, type of question. And so just be really careful when you're doing this type. So you still are just going to be multiplying these together. So square root of 3 minus square root of 2 times 2 square root of 3 plus 7. Right, so we are going to be foiling this. Let me do these, you know, kind of separately. So I'm doing square root of 3 times 2 square roots of 3. Remember, like our outside numbers are multiplied together. So 1 times 2 is 2. And then my roots are multiplied together. So square root of 3 times square root of 3 is square root of 9. Okay, and if I do my next one, square root of 3 times 7, whoops, I have to do a different color. Right, that's going to give me plus 7 square root of 3. And I can only multiply them together if they are, you know, I can't get square root of 21 because 7's not inside the square root. Okay, so let's do the inside terms. So I've got a negative 1 times 2, so it's going to be a negative 2. And then square root of 2 times square root of 3 is square root of 6. And then negative square root of 2 times 7 is going to be minus 7 square root of 2. Right? And then really the only thing that we can simplify here is this first term. The square root of 9 is 3, so we're doing 2 times 3, which is 6. And then the rest of that, do you see how there's no like radicals? So nothing else could combine together. But if there were like radicals, make sure that you do combine those together. Okay.
How long do we have to take the final?
How long?
Yeah.
2 hours.
Okay.
Yeah. So there's 25 questions in 2 hours. So, I think here. You make sure you know the distance formula and the midpoint formula. And make sure you know how to use those. Make sure you know how to multiply complex numbers. We did one of these last time in class too. Trying to look through and see which kind we haven't done that would be good to know. Go back up. Let's do 50. Okay. We did one like this before, but I want to make sure you're really feeling good about how to find the center and the radius. Right, so this is given to you in general form, but you need to change it to standard form so that you can find the center and the radius. Right, and so to do this, you've got to do the complete the square. Okay, so remember, first thing that you're going to do is you need to, I'll just write it down here. So I've got x squared minus 4x plus y squared minus 6y minus 27 equals 0. So first thing we want to do is take whatever our constant term is and move it over to the other side. Okay, so that's going to give me x squared minus 4x, and I'm going to go ahead and put my blanks in that I'm going to be filling in with my complete the square. So put these x's together, so plus blank, right? And then I've got plus y squared minus 6y plus blank, right? So I'm trying to make these two perfect square trinomials. But if I add those numbers to one side of the equation, I've got to add those same numbers to the other side of the equation. Right? So this is where the completing the square comes in on this. Okay? All right, so when we do this, right, we're going to take half of our middle term, so that's -2, and square it. That'll give me 4. Let's actually do it with colors here. And then here I'll take half of that and square it, which will give me 9. Add 9 to the other side as well. When I factor this, right, it's going to factor to be x minus 2 times x minus 2, so I'll have x minus 2 all squared. Right, plus this factors to be y minus 3 times y minus 3, so I'll have y minus 3 all squared. And then if I add all of those together, right, so the 27 plus 4 plus 9 is going to give me 40. Okay, so what would my center be for this?
2, 3.
Yeah, right? Remember, insiders are liars. Okay, so we've got 2, 3. And then the radius is not 40, but it's the square root of 40. Right? And if that can break down to be, you know, like if you can simplify that radical more, you're going to definitely want to do that. Right?
2 square root 10.
Yes, perfect. 2 square root 10 would be our answer there for the radius. Unless it asked for like the radius to be written as a decimal, then just leave it in this form. But usually on the finals, I would say, oftentimes they come out like these numbers that you come up with here are perfect squares. You know, so maybe you'd come up with like a 36 there or something instead. So, we really are trying to make sure, know how to do the stuff, but, not putting too much stuff in there, like just making sure we're getting you tested on the stuff you need to know. Okay, so remember, if you can't factor a quadratic, that you've got to use either completing the square or the quadratic formula, right? So on these, and again, it doesn't matter, like on here it's saying, use these to do complete the square, use these to do the quadratic formula. It's not going to, I'm not going to know on there which way you're solving it, and really I don't care. Both ways get you there, and so both ways are great for me, right? So let's look, and I'd say most students will probably only do completing the square on this circle one, because a lot of students aren't really big fans of completing the square, but maybe in 1050 when you do it, use it a little bit more, you might see, oh yeah, that can be kind of a good thing, right? All right, so let's do 54, and let's see. Yeah, let's just do that first one. So if you're asked to solve this, right, so 2x squared plus 9x plus 8, right, so I'm just going to use the quadratic formula, so a is 2, b is 9, and c is 8, right? And then put that into the quadratic formula, so x equals negative b, so it's going to be -9 plus or minus the square root of 9 squared minus 4 times 2 times 8, all over 2 times 2. Right? And so then if I, there, let's do So negative 9 plus or minus. Now let's figure out what all that is inside there. Right? So 9 squared is 81 minus 8 times 8, which is going to be 64. So that's going to give us 17 inside there. And then all divided by 4. Okay, and again, notice that this says, you know, give the exact and approximated solution. Well, on the final, it'll only ask you to give it one way or the other, but they're just trying to make sure that you know how to do that, right? So this would be the exact answer, right? And these are those two different answers. But if it asked you for the approximated ones, rounding to the nearest tenth, right? So you're going to do negative 9 plus the square root of 17 divided by 4. And so I get a negative 1.2, right, for one of them. And then if I go the other way, negative 9 minus the square root of 17, and divide that by 4. That's going to give me negative about 3.3. Okay, so those would be my approximated answers. Okay. So just make sure you know how to find, like, when it's the exact, it's asking you for that, or if it wants it approximated, really make sure you're watching closely where it's asking you to round to. Okay, I don't want you to miss an answer just because you rounded it to the wrong place value. Watch for that closely. Okay. Now, you won't have to do any U substitution stuff, so I'll just put that out there. Don't worry about that. You'll talk about that more in 1050, and that's kind of where they will test you on that more. Okay, but we're just kind of introducing it here, so don't spend time worrying about U substitution stuff either. Okay? All right. What about graphing these quadratics? How are you guys feeling about the vertex form and the standard form, being able to find the vertex, intercepts, and line of symmetry?
Can we do an example of that?
Yeah. Would you want to do one way more than the other, like the vertex form or the standard form? Either one's fine with me.
I don't really care.
Okay. Let's do the vertex form just because we'll be using the standard form on some of these other ones to find those things. So let's do this one. So if we have y equals negative 2 times x minus 3 all squared plus 3. Right, so we want to write down the things that we're going to try and find. So we want to know the vertex, we want to know the y-intercept, we want to know the x-intercepts, and then we want to know the line of symmetry. Okay, so what would our vertex be?
Would it be 3, comma
3? Yeah, it's going to be 3, 3, right? Remember, insiders are liars, so that's going to be a positive 3. And this one's not inside anything, so we just leave it how it is. Okay, so our vertex is 3, 3 on this one. Okay, how do we find the y-intercept?
It's going to be the b, so it's 0, 0, 3.
Okay, so, yeah, because you would just let x equals 0, right? So it's not, if it's in standard form, you could say, like on the other one on 58, that negative 1 is the y-intercept. Okay, but let's look here and see if that's true also here. Because remember, to find the y-intercept, we let x equals 0. So I'd have negative 2 times 0 minus 3 squared plus 3. Right, well, 0 minus 3 is negative 3. Squared is 9, so I really get negative 2 times 9 plus 3, which is negative 18 plus 3. So negative 15, right, is going to be my y-intercept. So be really careful on this. If it's in vertex form, we can't just say that it's that 3. We can find our vertex easily, right? And when it's in standard form, we can see the y-intercept easily. But we can't see the y-intercept all that easily when it's in vertex form. Okay, so our point, the way we write that down, would be 0, negative 15, right, is our y-intercept. Okay, and how about x-intercepts? How do I find those?
Your y equals 0.
Yeah, so we're going to put 0 equals negative 2 times x minus 3 squared plus 3. Okay, and now we just need to solve this here. So I'm going to start by subtracting my 3 over. Oops. So I'm going to get negative 3 equals negative 2 times x minus 3 squared. And then I'm going to divide by negative 2. So I get 3 halves equals x minus 3 all squared. And how do I undo squaring something?
Square it.
Yep, square root it. So I'm going to take the square root of both sides. Okay, and so that means when I take the square root here, that's really plus or minus, okay, the square root of 3 halves equals, well, these guys undo each other, so I'm just left with x minus 3 on this side. And then the last thing I need to do is just add my 3 over. And I'm going to add it in front of that plus or minus sign. So I get my x equals 3 plus or minus the square root of 3 over 2. Right. And, you know, make sure, I mean, on here it doesn't say how to write your answers, but on the test it would tell you whether it wants it in this exact form or whether you need to change it to a decimal form. Okay, those would be your x-intercepts there. Okay, and then how do we find our line of symmetry? Put it over here.
So the x-intercept is just 3 plus or minus the square root of 3 over 2?
Yeah, I mean, so there's 2 different ones, right? So it's like 3 plus the square root of 3 over 2, comma 0, and then 3 minus the square root of 3 over 2.
Okay, and those are both x-intercepts?
Yep, because it's going to be hitting the x-axis in 2 different places. Yep. So we have 2 answers there. And we expect to come up with those 2 answers because it's a quadratic, right? Exponent.
Yeah. And then what would be the line of symmetry?
Yeah, what do you guys think? How do we know what the line of symmetry is? Do you remember what it's related to?
I think it's the x value of the vertex.
It is. Okay. So if you're looking at the vertex, that x value right here is telling us that. So the line of symmetry is going to be x equals 3. All right, so if our x value was 5, then we'd say our line of symmetry is x equals 5, and so on. Okay, so it's always related to, because the line of symmetry is going through the vertex. Okay, and if we just graphed this really quick, maybe it'd be a little bit easier to see. Let me just try and graph at least this a little bit. So, so vertex is 3, 3. Here, and then since we know it's negative and we know it's going to be upside down, we know our y-intercept is at 8, 9, 10, 11, 12, 13, 14, 15. Okay, so it's going to be kind of looking like this, right? And it should be kind of looking skinnier because of that 2 also, right? That negative 2 in the front makes it upside down and skinny. And so that's what it would kind of look like. And then you can kind of see where your x-intercepts are. They're going to not be, you know, on whole number answers. But if you were to figure out what that, you know, decimal approximation is there on both of those, you'd see kind of like right there. Okay. Okay, what about number 59? So, like, how long after the object is thrown will it be 100 feet from the ground, when will the object hit the ground? So we already did one like that where it hits the ground, right, where we let our height equal 0, right? And on part A, we would just let our height equal 100 and solve that. Okay, but we haven't done one like 59C yet. So let's look at that. How do we find the max or min of these quadratics, right? So we're given h equals negative 16t squared plus 12t plus 200. And it asks us to find, what is the max height. Okay. So how do we go about finding this? How do we find maximums or minimums?
Finding the vertex.
Yes. Okay, so you've got to know that vertex formula. It's going to be the easiest way to do this. So the first thing we're going to do is solve for our t. Right, so t equals the negative b over 2a. Right? And so that means we're going to have, so negative b is going to be negative 12 over 2 times negative 16. So negative 12 over negative 32. Right, and let's just change that to a decimal here, which is going to be about 0.375, right? So remember, this first thing that we're finding is time, right? It doesn't make sense as height, right? It's only 0.35, 375 feet off of the ground. No, right? The maximum, so this is the maximum, the time when it's going to reach its maximum height. So at 0.375 seconds, right, it's going to reach its maximum height. And then we need to plug that back in, put that in place of t to find out what h is. So we'll have negative 16 in place of t, put in that 0.375 in both places there. And then just simplify that to figure out what that max height would be. Okay, make sure you use those order of operations, or if your calculator will just do that whole thing, that is fine too. Okay. Let's see. Okay. I came up with 202. Right, and here it didn't say where to round our answer, but it was 202.25 feet. Right, is the maximum height.
I didn't square. I didn't square after the 16, that first 0.375.
Okay, yeah. And
They
I could have.
didn't throw it very high.
What's that?
They didn't throw it very high from their starting point.
No, they didn't. But that's why it only takes 0.375 seconds, right, to get there. Because it really only went up a couple of feet, right? So it's kind of like, it's more like a parabola. It's going to look kind of, like this, where it's not going up very high at all. But yeah, that's exactly right. So they must have an arm like me when they're throwing a ball. It goes more, more horizontal than it does vertical. All right. What about?
Well, I have a question.
Yeah.
Sorry. So you thought of that, like when we are rounding, we don't round until the very end, right?
Right. Yep. So.
Should I just wanted to clarify?
Yeah. So make sure you don't put this as like 0.4 or something like that. Use the 0.375. Yep. And then don't round it until the very end. But on this one, it didn't even tell you to round to any place, so I just left it without rounding it. So, but yeah, make sure on those, don't round until the very, very end. Otherwise, you're going to get off by just a little bit there. And that will be sad. Some Okay, what about in finding the inverse of functions? How do you guys feel about that? Do you want to look at one of those?
Yeah, I'd like to look at those.
Okay. Let's maybe do that second one on there. So call it 62B. So that one says g of x equals 3x minus 1 all over 4, right? And it wants us to find the inverse. So when you're given a function like this, right, there's like 4 steps that you should follow to find that inverse. So the first step is change your function notation to y, right? So we're going to change that g of x to y equals 3x minus 1 divided by 4. All right? And then we're going to switch our x's and y's. So if I switch where the x and y is, I get x equals 3y minus 1 divided by 4. And now I want to solve for y. All right, so the steps we're going to change to y, right, and then switch x and y, and then solve for y. So to get y by itself, right, we got its denominator here, so we're dividing that all by 4. So if I multiply both sides by 4, I'll be able to get rid of that denominator. So I'll have 4x equals 3y minus 1. And then if I'm solving for y, let's add the 1 over. So 4x plus 1 equals 3y, and divide by 3. And then the very last step is that you're going to change back to function notation. So you've got to change it to the, the inverse of g of x, because we were given g of x first of all. So then we write our answer as the inverse of g of x equals 4x plus 1 all divided by 3. So on those, if you know those 4 steps, right, then you can really do that for any kind of function that they give you. But remember, you can only find inverses for functions that are one-to-one functions, and they won't give you anything that's not a one-to-one function if they're asking you to find the inverse of it. Okay, so don't be worried that they're trying to trick you or something like that. They will give you a one-to-one function that you can find the inverse of. Okay. All right. What about that like basis property? So like on 64. Okay, so on this one, if we are asked to solve 4 to the 3x minus 6 equals 16 to the 2x power. So what do I need to do with my bases here?
Same basis?
Yeah, we've got to get those to be the same, right? So you could see that we could get them both to be 4s, right? Because 16 is 4 to the 2nd power. And so then I still have that 2x in the exponent that I need to multiply by that other 2. But now that the bases are the same, I can just set those exponent parts equal to each other. So 3x minus 6 equals 4x. And then just solve for x. Looks like x is going to be negative 6 here. And then again, you could check your answer by putting negative 6 in place of x into the original equation and make sure that works out, right? Because it's a solved one, so we can always check this. Right? And then, what about solving something like 66? We're solving a log now. What would be a good first step on this one? How are we going to go about solving that?
Which part of 66 are we doing, A or B?
Oh, sorry, A. Yeah. So log base 2.
So you would do 2 to the 5th power equals 3x plus 1?
Yeah. Alright, so change it to that exponential form. 2 to the 5th power equals 3x plus 1. So 2 to the 5th, 2 times 2 times 2 times 2 times 2 is going to be 32 equals 3x plus 1. Subtract the 1 over. And then divide by 3. So x equals 31/3. And also on these log ones, they're not going to give you an answer that would make you get a negative. You remember how we talked about in class how, if you can't take the log of a negative number. So whatever answer you come up with here is going to be one that works. Okay, so don't worry about that on logs. You'll talk about that more in 1050, and they'll get more into that whole idea of, not being able to take the log of a negative number. Okay, do make sure that you know how to graph exponential functions and log functions, and even, maybe on your notes, on your note sheet, you might want to just write down, just some, things like, kind of what some of these look like. So if I have like 2 to the x power, right? So that's an exponential graph that kind of looks like this. Just do a rough sketch of it. Where if I have, f of x equals 1/2 to the x power, right? And that's that exponential decay, so it kind of looks like this, right? And then if you want to just draw some log ones too, right? The log of, like this or something like that, right? Your log graphs look like. Maybe kind of like this. Okay, and so on. So you might want to, just put a few of those down and make sure that you know what the rough sketch of each of those are like, because that could be really helpful. If it's multiple choice, think about on your homework and stuff like that when they were, saying, okay, match, this equation with these graphs, and they give you those graphs, and and so usually you can see, oh yeah, it's got to be this one because the other two, aren't even going to be, an exponential growth like this one is. So kind of keep those in mind too. All right, well, we've got, a few more minutes here, and I can go a little bit longer if needed too, but what kind of things did you come across when you were going through and studying for the test that you wanted to look at? Nada?
It's just very overwhelming because there's so much information, and I'm just really nervous for the final.
I know.
I don't know what kind of. It's like the A equals P, like trying to figure out like how much money it costs for someone to do. Like I forget how it is, like how the questions are asked. I just have a lot of those in my notebook for the start.
Just like finding the compound interest ones.
Yeah, like compounded interest. Yeah. Sorry, I had no idea what it's called.
That's okay.
Equation was
That's
down.
all right. I mean, would it help to know there's not going to be one like that on there?
Yeah, that'd be great. I did like 10 of those problems last night, just like looking them up, because those are terrible for me.
Yeah, no, I know, and that's what's so hard about this, because like Maeve said, there is a lot